Okay, now we want to talk about ocean circulation. And there are two kinds of ocean circulation. You have the surface ocean circulation and then the deep. So, first, we're going to talk about the surface ocean circulation and what causes it. This is going to be caused by winds. So, as winds blow across the surface of the ocean, it's going to make surface ocean currents. So before we can understand that, though, we need to go back and talk about what the Coriolis force was. So in a previous lesson, we talked about climate and we talked about global wind systems and how they were caused by the Coriolis force. So if you haven't seen that video, then watch this little video right here down at the bottom. So find that on YouTube and then watch it. I'll wait. Okay, did you watch it? All right, so let's summarize what happened in that video. So you had a merry-go-round. You had 4 people on it. It was rotating counterclockwise. Okay, so this merry-go-round was rotating in this direction. The host told this person right here to throw a ball to this person over here. Okay, so they tried to throw the ball directly to this person, but it looked like that the ball bent in midair and it went over here, and this person over here caught the ball. So the ball really did go in a straight line. So that's Newton's first law of motion. An object in motion stays in motion, goes in a straight line. So the ball really did go in a straight line. But because this thing was rotating, then by the time the ball got over to here, this person had rotated over to here and they caught the ball. So it's an optical illusion caused by the rotation of the merry-go-round. The same thing happens on Earth. So the Earth is spinning counterclockwise. And so that means that any wind system that is trying to go in a straight line is going to be bent to the right in the northern hemisphere. And then in the southern hemisphere, it's going to be bent to the left. So it's, again, an optical illusion. The winds really are going in a straight line, but the problem is that the Earth is rotating out from underneath them. And so here's a formula that allows you to calculate the Coriolis force. We're not going to do it, but you should notice that it depends on the speed of the wind. So the faster the wind is blowing, the more it's going to turn. You should also notice it depends on the latitude. So where are you located at on the Earth's surface? And it also depends on how fast is the Earth rotating. So all 3 of these things go together and it makes the Coriolis effect. So the point is, wind systems in the northern hemisphere are going to be bent to the right because of the Coriolis effect. Okay, then we combine this with the fact that the winds are moving because of convection. So that if this is the surface of the Earth, and then this is the hot area at the equator, then the hot air is going to rise until it reaches the stratosphere. And then once it reaches the stratosphere, it's going to try to go to the North Pole, and then it's going to come back down. And then the winds at the surface would go from north to south. So in the stratosphere, winds would blow from south to north, but on the surface of the Earth, they would be returning and they would be blowing from north to south. That's if the Earth was not spinning. But because the Earth is spinning, because of the Coriolis effect, this convection cell gets broken up into 3 convection cells. So that here's the Earth again. It still rises at the equator. It still tries to go north, but at about 30 degrees latitude, it comes back down again. and then it goes back to where it started from. Then you have another convection cell from 30 degrees to 60 degrees, but it's reversed. So here the air is coming down, here the air is going back up again. And then there's a third convection cell up here. And so here the air is coming down, and then the air is going up. And then we said that this is why the Earth has deserts. So located right here at 30 degrees latitude, the air is coming down. So that's a high pressure system. So it doesn't allow the formation of clouds. And so at 30 degrees latitude around the Earth is where you have bands of deserts, like the Sahara Desert. And then same thing is true down here in the southern hemisphere. Only the difference would be this would be negative 30 degrees latitude. So because of this Coriolis effect, you can see that you get these surface winds that are doing all of these surface winds are bending as a result of the Coriolis effect. All right, so here then is the surface ocean currents. So as the surface winds blow across the surface of the ocean, it causes the ocean to begin to move, so that you also are going to have surface ocean currents. And you notice that they're going around in these big circles. So that's due to the Coriolis effect. Okay, what about the deep ocean circulation? So this is going to be primarily due to temperature and salinity differences. So at the equator, the water is going to be warmer than at the poles. So water is going to tend to flow from the equator to the North Pole. And so it's going to be warm water, and that's represented by the orange lines in that picture. Okay, but then once it gets to the North Pole, it begins to cool off. As it cools off, it becomes more dense, and so it goes down until it reaches the floor of the ocean. And so let's start off in the Atlantic Ocean at the equator. Warm water is going to go up the coast of the United States, so that's going to be the Gulf Stream. It's a surface current because it's warm, it's not so dense. It reaches the polar regions where it cools off, becomes more dense, and then it goes down. So it's going to flow along the floor of the ocean, the Atlantic Ocean, and it goes all the way down to Antarctica. And then you can see that it curves once it gets around Antarctica, and then it goes up into the Indian Ocean, and then it starts to rise again because it's starting to be heated up. And then it makes its appearance in the Pacific Ocean, but once it gets up again to those northern latitudes, it's going to cool back down. It goes back down to the floor of the ocean, and then it goes again back by Antarctica, and it goes back up into the Atlantic Ocean. So these patterns are going to be because of density and temperature differences in the water. So the first picture is the top-down view of the oceans and what these different currents are and where they're at. And then the sideways view is the picture that's right next to it. Okay, so let's take a break. When we come back, we'll talk about what causes ocean upwelling and downwelling.